So hello everyone, and thank you for joining us today for our webinar on wire rope inspection and maintenance for your underhung hoist. Presenting today will be Peter Cook, our training manager covering rigging, hoist, and load securement. Also joining us today is Tom Reardon. He's our technical trainer covering cranes and hoists, and he's going to be available to answer questions throughout the presentation today too. My name is Gisela Clark. I'm the e-marketing specialist at Columbus McKinnon and will be your host for today's webinar. We are recording the session, and as I said earlier, the recording link will be added to our YouTube channel. All in attendance will receive a link to the recording. Everyone is in listen-only mode, so we encourage you to ask questions in the Q&A pane on the right side of your page. We'll take 5 minutes of questions at the end, and any questions that don't get answered, we will be sure to have Peter or Tom follow up with you after the webinar. So all of your questions will receive a response. Thank you for your attention, and now I'll turn the meeting over to Peter so we can get started. Peter?
All right, good morning, everybody. So we'll get started. So today's topics are to cover a little bit about wire rope construction. We're going to go over some of the rejection criteria, and then what maintenance and lubrication you can use to try to keep your wire ropes in good shape. And that's probably the key element. Last month or two webinars ago, we did something about chain for hoist, and now we're going to go over to wire rope, and so hopefully we can keep all the hoists safe out there by doing these webinars. Again, these webinars aren't any substitution for government regulations and safety standards such as ASME or OSHA. So always, you want to obtain those documents, review them, and get properly trained. This is more of a general awareness webinar, and hopefully we can teach you some things and point you in the right direction. So let's start off with how is wire rope constructed? Okay, well, wire rope is made up of a strand. Okay, it's a pretty round-shaped wire, typically laid around a center in one or more layers, and those strands are laid around a core. Okay, and the core of the wire rope is an axial member around which the strands are laid to form a wire rope. And we can have different types of cores. We can have independent wire rope core, and you'll hear the term IWRC. That represents independent wire rope core, and that's the most common that's used out there. And then there could be a fiber core, it's synthetic or natural fiber, or what they consist of. And of course, the shape of those strands, they can be preformed or normal shape. It all depends on what the engineer and what that wire rope they want to accomplish, the characteristics of that wire rope. So it's always important that any time you're replacing the wire rope on your hoist that you call the manufacturer and be sure to get the right wire rope. Even though you may think it's a certain diameter or certain types of strands, you just want to verify what it is and call the manufacturer. So each strand is made up of wires, which is just a basic element of wire rope, and a single metallic wire. It could be either round or shaped. The center of each strand has a center, and it's actually a member of the strand which lays about lays around the wire. And then you have a rope lay, and the rope lay is a distance measured parallel to the axis of the rope in which the strand makes one complete revolution around the core, and that's known as a rope lay. And we have some other terms that we call a lay as well, and we'll get into that in a little bit. So if you were to cut the end of a wire rope, this is what it looks like. And look here, the rope that we're showing now is a 6x19 classification, which means it has 6 strands, and of course you have your independent wire rope core, and then if you take one of those strands, it could have up to 16 to 26 individual wires that make up that strand, and that will be called a 6x19 classification. And then you have a 6x36 classification, which could be 27 to 49 wires in that strand. So each of those individual wires and all make up the wire rope, and each individual strand, and they all work together. So it's a complex machine working together, moving and creating strength and flexibility that operates our hoist. And then we have different grades of wire rope. We have IPS, which is improved plow steel, and then we have EIPS, extra improved plow steel, and then we have EEIPS, which is extra improved plow steel.
Peter, you said wire rope is made of plow steel, but what is plow steel?
Well, that's a good question, because what is it? It's maybe not a term everyone's heard or understands, and it's actually originated in England. It was a high quality, strong steel and actually used to rig steam engines to haul gangs of plows across the field. So there's the term plow where it comes from. So as technology advanced, we got better grades, so they used the term improved plow steel, extra improved plow steel, then extra improved plow steel. And each of those have their material strength that you could look up, and it's a tensile strength on there. So we look at, in order to figure out what you have to look at the original tag of that wire on the reel that wire rope came in on, and you don't want to lose that information on that, because once that is gone, one disadvantage to wire rope is it can't be easily identified as far as what grade it was. So it's very important that you keep the paperwork on that.
Okay, thanks, Peter.
But good question. That's a good question. Yep. And so we talked about lay. So lay also means strand in the wire position on the rope. So we have right regular lay, and so the wires are lined in one direction, and the strands are the opposite. So you can see there that the strands are going to the right, and then you can see each individual wire kind of looks almost parallel there. That would be a right regular lay. And then left regular lay, the strands are going to the left, and the same with individual wires, that they look almost parallel when you look at it in a horizontal position. So, depending on what hoist you have, and as Tom can elaborate, maybe there's some applications for left regular lay, Tom?
Yes, with hoists, especially with hoists using rope guides, depending how the drum is machined, it becomes important to use left lay in some applications. If not, a rope guide can tend to unravel or unwind a wire rope. But prior to really recently, the last 12 years, regular lay was pretty much the standard across the board, but not necessarily so anymore. So you may see left lay anywhere.
Thanks.
And then we got Langley, where the wires and strands are wound in the same direction, as you can see here. And then you get better characteristics in resist abrasion, increased flexibility, fatigue resistance compared to the regular lay. But you're going to get, you kind of chase your tail, but you're going to get some characteristics that you don't see in the regular lay. That's prone to kinking and unwinding. And then you have alternate lay and alternate strands of right regular lay and right Langley, which are mostly used for boom hoists and winch lines, and has features of both regular and Langley. And Tommy, if you want to elaborate on any of those and what their applications are for those.
Typically, there is no application for either one of these examples when it comes to hoists and cranes.
Okay, so we're mostly talking about mobile.
Maybe a little bit for alternate lay, which sometimes gets the name of rotation-resistant type wire rope.
Okay. So the three meanings for the lay are the distance one strand makes in one revolution about the core, wire direction in the, and the direction of the strand in the rope. So those are all the terms so that's how the rope is constructed, and those are the terms that we use. So let's get to the important.
Uh-oh. Peter?
And when yes.
We just lost you for a second. Just wanted to make sure. Okay, go ahead. Sorry.
Okay. Yeah. So let's talk about the rejection criteria. So when we look at, we take measurements when we do inspections. Operators aren't going to do this, but your maintenance crews are, and they want to take measurements every so often. What seems acceptable. There's really no specified distance or how many times you have to measure it, but you definitely want to look at the areas that are being most used in your running ropes. So there's a wrong way and a correct way to measure that. You can see if you want to measure across the crowns and not on the flats, because you'll get a different reading. And reductions from nominal diameter greater than 5% we want to reject, and reductions that are due to loss of core or support of internal or external corrosion, we want to reject that as well. And so if you look at those pictures there, these are the end terminations, a close-up of an end termination on the wire rope, and we got a couple broken wires near the end terminations. And in destructive tests, wire ropes usually break where the rope enters into the terminations. So therefore, when we do training, we say that, if you're finding any broken wires in those areas, you need to remove it from service. We're not sure what's going on beyond it, inside that termination. So your best bet is to remove from service if you're seeing any broken wires in those areas. And then in 2012, we used to talk about broken wires within the lays, And in 2012, ASME B3016 updated their document a little bit, and it's actually I like this a lot better because it's more field usable. They used to talk about broken wires in a lay, and it was hard for people to understand, like, what's that? How do I measure that lay distance or getting the correct distance? So what they did here is they took they used rope diameter, so that's easy for someone to do in the field. So for running ropes, 6 randomly distributed wires and 6 rope diameters, which means the broken wires are not on the same strand. And so you measure your diameter, then times that by 6, and so you measure that distance, and you're allowed to have 6 randomly distributed, and then only 3 in 6 rope diameters if they're on the same strand. Rotation-resistant ropes, 2 randomly distributed broken wires and 6 rope diameters, and 4 randomly distributed broken wires and 30 rope diameters. Removed from service. Kinks and dog legs.
Why do they call them? Why do they call them dog legs, Peter?
I'm not sure. Tom, you know the word dog leg? Why they call that?
Yes, it's just a slang term. You will never see the term dog leg used in any technical publication. It is a kink.
Just a kink.
Yeah.
Okay.
But it is a slang term that's common in the industry.
Okay. Thanks.
Yeah, and what the kinks do, the wire, if you ever look at the way, if you look at a shiv or how a wire gets wound around the drum, the wires will actually adjust and move as they go around shivs. And when a wire kinks, it can no longer do that. And I always refer to the paperclip example. If you were to open a paperclip and bend it, keep opening it and bending it, it eventually breaks. So basically what you have is this kink, and what you're doing is as these kinks are going around shivs or being tensioned, they're opening and closing, and they're not allowing the wires to adjust, so therefore you start getting breaks, fatigue breaks. And so kinks are a big issue. Not all the time are kinks very well pronounced. There's sometimes like a gray area, like, whoa, geez, is that a kink? Well, it's definitely not perfectly great, but it's not really that bad. And Tom, you have a good explanation of that. It's just in those gray areas, if you can elaborate.
It comes back to the different slang. You have a dog leg and you have a kink, but any permanent deformation of the rope structure reduces the individual wire's ability to slide. There is certainly a point where we don't replace a wire rope just because it has a slight wave, but you have to be very careful of that. Any permanent distortion of the rope structure reduces sliding of the wires and accelerates fatigue. About as simple as I can put it.
Mm-hmm.
Very good. And then we got core protrusion, and this is where the individual wires are intact, but actually the internal core is failing. And so it could be, in that top picture, that's a pretty exaggerated. But you can have one small little wire coming through, which is called a valley break, and it may not seem that bad from the external visual, but if you see that, that means your internal core is failing, and that's immediate removal from service. So if someone's not trained properly, they may think, well, that's only one broken wire within, Pete, you said six diameters, and that's only one broken wire, so I'm good to go. And in this case, no, it's not the wires that are broken. It is actually the internal core, and that's an extremely dangerous situation. You want to remove that immediately. And so these are just different examples of those valley breaks. And then here's a picture of the strands removed that had these individual valley breaks, and you can see how bad that internal independent wire core looked. It was, basically it's all broken up and failing, and so that's a rope that's ready to fail. And that's basically that happens from a lack of lubrication, not properly lubricating that, or getting we'll get into that in a little bit, lubricating the wire rope. But when you don't lubricate, it's gonna, and moisture gets in there, it can rust from the inside out, and so that's what's happening. So obviously corrosion is not a good situation. Fatigue breaks, which are squared ends, so you want to look for that. It may not be wires that are pronounced with breaks or that you can actually see. There might be small individual little cuts. So those are things you want to look for as well to remove from service. Bird caging, which we didn't cover yet. Sudden release of the load, a shock load, will cause this bird caging effect. Twists, distortion, all those are removal from service. And that was just a quick, brief things that operators can look for and find in their pre-operational checks that they should be, every day if they're operating that crane, they should be doing that and getting maintenance attention immediately anytime they find anything they hem and haw about, get it to the attention of maintenance or a certified hoist repair technician, have them come out and look at it.
Okay, Peter, I'd like to go ahead and have a quick polling slide for everybody. So here's the question. If you're on an iPad, you can just shoot me your answer on the Q&A pane because I don't think the functionality works. But for the rest of you, you can vote. How many randomly distributed broken wires are allowed in 6 rope diameters for wire rope on an underhung hoist? Is the answer 3, 6, 9, or 12? Again, how many randomly distributed broken wires are allowed in 6 rope diameters for wire rope on underhung hoist? Well, let's see. It looks like just about 40% of you are voted. We need a few more. Okay, let me just see here. Looks like we've got, all right, 60% of you voted. Looks like a third are thinking 3. 2/3 are thinking 6, and a handful are thinking 9 and 12. Can you share the answer, Peter? I'm going to go ahead and close the poll. Thank you, everyone, for voting.
The answer to that question is 6.
6. Okay, thank you.
Okay, and again, that the B30.16 document, 2012 document that was kind of updated. We used to go by the lay length and count broken wires, but now we go by the diameters, 6 diameters, which is a little bit more field friendly. Okay, so let's talk about lubrication. Is definitely going to be any time we have, just like when we talked about our chain limit, our lubrication is so important. You can imagine rubbing your hands together dry at a very fast speed, and you can't do that for long. That generates a lot of heat. So can you imagine all these individual wires that are dry that have to adjust themselves and move under extreme tension, how hot that must get, then going around and things of that nature. So, and plus you got surface-to-surface contact, right? These wires are moving about each other, and anytime you have surface contact, that's going to cause wear. So lubrication will act as a buffer between those surfaces and also and minimize friction, and that's all going to minimize wear. Obviously, we're going to have load, and it's inherently in the nature of just operating a hoist. You've got surface-to-surface contact, so wear is going to happen at some point in time. But the best way we can minimize that is to keep properly cleaning it and lubricating the wire ropes when necessary. All right, so there's really no time frame to give it how often. It's basically just the operator should be looking at that rope, and if they can see that it's dry, that they're going to need to get maintenance out there and lubricate it properly. So types of lubricants, what do we want to use? So there's 2 types of lubricants that you can use. There's penetrating lubricant and a coating lubricant. So penetrating lubricants contain a petroleum solvent that carries the lubricant into the core, and that's really, we want to get that core lubricated. We saw that picture of that core failure, and that's something we don't want because an operator really can't visually see that, and maintenance really can't really see that. So it's really important that we take care of that core and get that lubricated. So it carries the lubricant into the core of the wire rope and then evaporates, leaving behind a heavy lubricating film to protect and lubricate each strand. Displaces water, replaces it with oil. That's important, right, because we don't want internal corrosion going on. Reduces abrasive wear inside the rope. And it washes off all the external surfaces and removes contaminants and dirt. Now, you don't want to use a lubricant that's going to prevent inspection, so it's something that's going to be extremely thick or have like a coating on it, because they're going to have to get that off to properly inspect because it's going to cover up a lot. Coating lubricants penetrate slightly, sealing the outside of the rope from moisture and further reducing wear and corrosion and minimize wear contact with external bodies and shivs. So that's important, right? Because they got that penetrating lubricant that gets to the core, and then we need something to protect from the shivs, and then, also from the elements. And that's you're going to want to use a coating for that. So a combination of both is ideal. So if you can use your penetrating lubricant and then a coating lubricant, you're going to have extremely long life of that wire rope. You're going to get the full life cycle out of it. Okay. So before you do any type of inspection or re-lubrication, you want to clean hardened lubricant or dirt and other contaminants with a wire brush and petroleum solvent, compressed air or steam cleaner before re-lubricating, and then dry immediately and get lubricants. Hopefully you don't have to do that, but outdoors that may happen where it needs to be cleaned. Field lubricants can be applied by a spray, a brush, by dipping it and dripping it. A pressure boot, which there's companies that sell pressure boots that pushed it into the core, and you just run your hoist and it runs through this boot. This is kind of really a neat thing. You can Google some of those things, and I think I forget what company it was, had a really nice video on one. But if you're doing you're doing a spray, a brush, or a drip, the best place to apply it is obviously the drum or the shivs, because the wire rope tends to open up in those areas so that the core is a little bit of exposed, and so those would be the proper areas to lubricate it, rather than trying to lubricate wire rope in the straight areas where it's kind of closed shut. So that was just a basic overview of wire rope inspection and maintenance, and at this point we can open it up to any questions.
Well, I'd like to ask one more polling question while you all are thinking of your questions. Just one second. So I know someone sent us a quick question about lubrication. What is the best lube to use for most wire rope? And here we have a polling question. So which type of lubricant is good for saturating core? Is it coating type, heavy grease, penetrating, or graphite? Again, is it coating type, heavy grease, penetrating, or graphite? Looks like the good majority are voting for penetrating, 99%. So, Peter, what's the answer?
That's absolutely right. Penetrating is the best to get to that core to lubricate it.
Excellent. Okay, so now would be a great time for you to type in your questions. You can feel free to do so. And I don't know, Tom, in the meantime, just for a quick sec, well, here we go. Is the degree of kink still used to determine a violation? This question comes from Stephen.
Who do you want to answer that? Me?
Sure.
I'm going to go strictly with the ASME standards. And ASME standards say that anything results in permanent distortion of the rope's structure is a reason to take it out of service. Any deformation is a kink. It's just a matter of how bad they are.
Okay.
Final answer.
Okay, and really quick, I know we have a few people on the call that are not from the United States. So the ASME, that only applies to the United States, or is it just the U.S.? I mean, just America.
Okay, well, any distortion, and I mentioned it before, any distortion in a rope structure restricts the individual wires from sliding.
Okay.
If they cannot slide, they're going to bend. If they bend, they're going to break on
Yes.
water fatigue.
So this is just a standard. Okay, gotcha.
Yeah,
Okay.
plus Keith, even if someone had one of our hoists with wire rope, the manufacturer, if you look in our maintenance manuals, we will reference the ASME standards or CMAA standards. So even if they're in another country, the manufacturer,
Our standards apply, yes.
It would apply because those are written into our maintenance manuals, and I'm sure their standards in their country would say reference the manufacturer's maintenance manual.
Okay, that's an excellent point you bring up. Good. Okay, so another question. What causes a bird cage? This is from Fred.
A shock load or sudden release of the load. So maybe the load was hung up on something, and you're hitting the up button, and it all of a sudden releases and flies up in the air, and then drops. That's a shock load. Or something was up on a table, or and you move the crane and the load fell from a specified height, and of course then the hook and the rope catch it. That's another term used as shock load. Or the crane operator is just coming down too fast with the load and hits the ground. That's a sudden release.
Okay. Okay, excellent.
And so that comes up the works when that happens.
Okay, gotcha. Good. All right. The next question is from Todd. A hoist is in service for 2 months with no issues. Suddenly the load block wants to twist when lowered. What is the cause of this?
I refer to Tom on this one.
Okay, Tom, you're on.
Everything's fine for 2 months, and then the load block wants to twist?
Yes.
Is that the question?
Yes.
This is just an educated guess that once the wire rope has been in service for a while, there can be some twisting or relaxing that goes on. And either it relaxed and went back to what would have been a natural twist in the first place, or it has stretched, not meaning that detrimentally. It has stretched a little bit, which has induced the twist. On the empty block, I assume is what he's asking.
Okay. All right. Very good. Thanks. Troy has the question. Can you please explain the 6 diameter rule?
For the ASME that we explained, yeah, that's basically you take a measurement. Let's say a rope is 1 inch diameter. So therefore the 6 diameter will be 6 inches. So 1 times 6 is 6 inches. So you would count broken wires within that 6 inches, and you would go by that rejection criteria of how many broken wires are within. So that's a small distance that you need to check for broken wires, and that goes. You have to do the whole rope that way, and that determines whether you're going to reject the rope or not. So if I only had 1 broken wire within that 6 inches, I'm still okay. I can still use that hoist and not have any problems with it.
Okay. All right.
But you'd have to go, again, I want to reiterate, you've got to keep going through the entire wire rope for inspection.
Okay. Excellent. Next question comes from Frederick. Is there an obligation to measure the wire rope diameter, or is a visual inspection sufficient? I ask the question because this would be required to measure the rope at many different locations, and also to clean the rope at these locations, which is not always practical.
Well, I mean, your inspection, your visual inspection, you're going to go through visually, okay, and then you're going to, if you're finding broken wires, there's where you're going to take your measurement and see, okay, if it's a 1 inch wire rope, do I have a lot of broken wires within that 6 inches? And if there's 6, randomly distributed, you would reject. So there's where you would need to know, okay, how many wires can I accept here? So that's where you need to take your measurement. You would still do it, visually. You would just keep going visually through it and then you would stop when you find an abnormality. Now, as far as the looking at a diameter reduction or an increase in diameter, you're just basically have to do random sampling based on what you're seeing visually. If something looks a little bit different, you're going to take measurements there. But you should be, it's almost like batch testing. You're going to have to kind of randomly take areas and measure it and see where you're at.
Okay. Perfect. Thank you, Peter.
And as far as cleaning is concerned, if you can't see it, you're not inspecting it. So unfortunately, you're going to need to clean it, because if you can't see it, what are you inspecting?
Okay, excellent. So we're going to take a few more questions. We were able to finish a little early with the presentation side. We have a few more slides to show you, but the good news is it's allowed for a few more questions. So we have about 5 more to go. What brand of lubricant do we recommend? This question comes from Troy.
I just, I would always, and I'll let Tom answer this too, but I would just say go to the hoist manufacturer for that particular hoist and see what they recommend. And other than, penetrating and a coating lubricant, I hate to be so vague, but that's, it's a safe answer.
What do we recommend for our own?
I'd have to look each hoist what it is, but I can get some samples of, what I'll do is I'll pull the manuals and I'll list them. We can send that out in email.
Okay, that sounds good. All right. What is the right way to set up the wire clips at the end of a wire rope? This question comes from Isao.
We have criteria. You have to know what the turn back is and the number of clips depending on the rope diameter. And of course, you have the saddle of the clip. You never saddle the dead end, so the saddle always goes on the live end. And the spacing and everything of that nature is spec'd out by the clip manufacturer of how to properly do this. And then they got to be torqued properly. So once the wire rope is loaded, it's going to kind of adjust, kind of like a braking period almost. And so those clips are going to have to be looked at again where you can torque them down.
Okay. All right. Let's see.
Well, each manufacturer specifies that.
Okay, gotcha. Thank you. Now, this next one, steel workers use wire rope. They always have pigtail wire rope they use over and over and over. How do we change their way of thinking? This is from Patrick. Training.
Just get them the proper training.
Okay.
And honestly, that's the best way to do it. They need to be trained properly on their equipment and the dangers of not inspecting their equipment properly and not following the rules. Because these rules and regulations that we cite, they're written for safety, but they're also written because accidents have happened. And so there's a need to have a rule for that. I'm not saying every rule exists because there's been an accident, but a lot of them do, unfortunately.
Yeah, that's a big problem that we have. You're right. You're right. Okay. All right. So, and again, for those of you that have asked questions that we might not have time to answer, we will respond directly. So, okay, a couple more. According to the Crosby standard, all of them have to go in the same way. Is this correct?
Yeah, that is correct.
Yes, it is correct. Okay.
I'm assuming they're talking about wire rope clips.
Probably so, because the question was regarding wire rope clips. Yes. Okay.
Yeah,
right.
Like I said, you never saddle a dead horse, and so they all, obviously you cannot put the saddle on the dead ends. They got to always be on the live end. They got to be spaced properly. The proper number of clips have to be used according to the rope diameter. So you need to check with the manufacturer of each clip, and they will lay it out for you as how you assemble those properly.
Yes, he said he confirmed they were talking about wire rope clips. Okay. So
yeah, and Crosby's a reputable manufacturer, so I sit with them on many boards, so good information there.
Great. Okay, excellent. Okay, two more questions. With the new rules are the new rules from ASME based on the diameter for broken wires? Let's see, based on the diameter for broken wires are equivalent to the previous rule. The number of broken wires in one rope lay. New rules from ASME based on the diameter.
It's probably fairly close. I haven't done the math on it, to be honest with you, to check it out, but I don't think they would go that drastically after the number of years that's been out there. Again, I don't sit on that particular committee, but I'm sure it's more field applicable to talk about diameter. It's easier to figure it out in the field by diameter and not a rope lay by trying to look at what the distance of that lay is, because
okay.
you could get some people improperly distances there looking at it. So
okay.
And I'm pretty sure they try to make things more field friendly.
Yes. Okay. I would like to add, I've seen over the years as a field technician that we would find the majority of wire rope failures at the top of the equalizer sheave if applicable. We found in most cases all the lube from the manufacturer was dried out, adding to the problem. The rope is always static and never moves through the equalizer.
Tom, you want to take that one?
that's an affirmative. Most people realize that. All it does is rock back and forth. It never really works, so it's not opening and closing, and the lubricant is not moving around.
Yeah.
It's the most common place to find wire rope degradation.
Okay. So it is a common problem.
Very much so.
Okay. All right. All right. This is the last question we'll take. And then, like I said, anyone else that has any, we will respond directly to you after the webinar. So let's just see. If you replace a wire rope that does not come from the manufacturer, is that any type of violation? And if so, why?
If you would, any warranty that hoist had would be no longer valid. Certainly if someone didn't get the rope from us and there was a problem or something prematurely failed, that we certainly would say that's not what that's not the rope we recommended, or it was intended to be used. So I would definitely, some manufacturers, I would call the manufacturer. Some manufacturers may say, hey, go and get, as long as you have this, let's just say it's as long as you have regular 6x19 wire rope, and they give you, that's fine, and they may give you permission to do that. Others may not. I know, like on our World Series hoist, they're pre-formed. It's a specially made wire rope specific to that hoist, so you couldn't go get it anywhere else. So again, I would just refer to the I just don't want to give a blanket statement. Refer to the manufacturer. They may tell you go buy this type of wire rope, or they may make you get it from them. But by doing so, again, you would then be responsible for the integrity of that equipment, because it may not be exactly what the manufacturer said.
Okay. All right. Thank you. That's the questions we'll take today. Like I said, any others we will gladly respond to after the fact. I want Peter just to cover quick a few of the upcoming classes we have in case any of you are interested.
Yeah, and someone asked how do we change the thinking of some operators and users or inspectors, and I mentioned training, and so if it's wire ropes for rigging, we definitely go over that in rigging training, as much of how to use slings and hitches and calculate centers of gravities and tensions, and it's all done in our qualified rigger workshop, with an option to certify as a certified rigger at the end of the course if you so want to do so. Overhead crane and hoist inspection and certification classes we run regularly. You can see the dates there, that are the upcoming dates, where those are being held. When I believe the March one, the March one is in near Buffalo, Niagara Falls area. The April one, we got one in Omaha, which may be sold out, and in Charlotte going on. But you can go to our website and get those cities. We have repair schools. So a lot of people get confused over the overhead crane and hoist inspection versus our repair schools. The overhead crane and hoist inspection is just that. It's inspection, external inspection of cranes and hoists on the entire systems, with maybe a cover showing how hey, you might want to remove a cover here and there to look at brakes, things. But the chain hoist repair schools or the wire rope hoist repair schools is strictly the hoist. We break every hoist down, every component. We go away from every bolt, nut, washer, total disassembly of every hoist, reassembly, what to look for, how to fix them, how to meter, electrification for electrical troubleshooting, and that's that type of class. So two totally different courses. And what you find is there are people out there who strictly do inspections, and there are other companies that strictly do repairs, and some do both. But so not everybody needs the repair tool. So we kind of split that up, but it's pretty extensive information that you need. There's no way we can combine the two. It would take too long.
Okay, Peter, thank you. And if you can go to the last slide, I'd like to let everybody know about how they can connect with us further. So for those of you on social media, personally or professionally or company-wide, we are all over on social media. We're on Twitter. We have, you can find us at CMCO Live. In fact, the best way to connect with us on social media is go to our website on the bottom, which is cmworks.com. And in the upper right-hand corner of our website, you'll see the icons. You can just click on any of the icons, and will take you right to our site. We're on YouTube, so after the session is over, I have the recording. I'm going to post there. You'll get a link to it via email. We're on Facebook. We share tons of pictures on Facebook. We love sharing there. I have a lot of engagement. You can also get updates on LinkedIn if you like that. We're on Google+. And we're even on Instagram, so share tons of pictures there as well of our products in the field and our fans, and have a lot of fun there. And last but not least, we have a blog, and on the blog, I think we're almost up to 150 articles. If you click on that little green button on our website, it'll take you there. You can subscribe to it, and you can get all different types of great how-tos, great question and answers, updates about our new products. But it's very much focused on what we think you might be interested in learning. We try to make it very education-focused as much as possible. So if that's something that interests you, we encourage you to subscribe there. But we just want to thank you for your attention today and your interest in learning more about all the topics that Peter covered and Tom. And as I said, we'll be sending you a link, and we hope that you have a great rest of the week. And any feedback you have on this, you can post it as a comment now, or in the email you can respond and let us know how we could improve, or maybe you have a new idea that you'd like us to teach about. That would be great. We'd love to hear it. So thank you, everyone.